This video is talking about quadratic functions when they are in factored or intercept form. We can choose between the words factored form or intercept form. They're talking about the same thing. Quadratic functions is when you're having the ax squared plus bx plus c, that's standard form. Factored form is when you have factored the quadratic and it is in the parentheses sets the product of its factors. You will have your GCF, which could potentially just be 1. You'll have your two sets of factors with your variable inside of it, with the numbers that will multiply to C, that will add to B, however you want to factor it. The first thing we want to find is, because it's in intercept form, this actually tells us our x-intercepts. If it's in factored form, it's in intercept form, which tells us our roots. Another word for roots are your x-intercepts. Another word for that is solutions and your zeros. All four of those mean the exact same thing. So if we look down here, we see f of x. F of x really just stands for y, because f is a function of x. So that means that we can say that this is just y equals. Now on this problem, we have the factors of x plus 3 and x minus 1. Again, they're called roots, and another word for roots are zeros. We ask ourselves, what values will make our factors equal to 0? If we look inside this first set of parentheses, because this is our first factor, we would set this equal to 0 and solve for x. In this case, we would just have to subtract 3 to get this equal to 0. Another way of thinking of this, what plus 3 equals 0? And in that case, this x value, if it is equal to a negative 3, this will give you 0. What we're going to use instead of x equals at the moment when we're talking about factored intercept form, we're going to use the letters m and n to talk about our two x-intercepts. Now I could use a and b or any two letters I want to really use, but I'm going to use m and n for the purpose of this video. So in that case, my m value is equal to a negative 3. I move on to the next factor, which is also inside of parentheses. It has the letter x with it, so that means that this will give us an x-intercept. In this case, we say what minus 1 equals 0, or we can set this x minus 1 equal to 0 and solve for x. And in this case, we would add 1 to the other side because 1 minus 1 gives you 0. So I can say x equals 1, positive 1. But again, for this video, we're going to make sure we understand that the intercepts, the x-intercepts, are m and n, so our n value is equal to 1. Now what we want to do is we want to find the roots and write them in coordinate form. Since they are x-intercepts, we write them as coordinates, so the x value is your x-intercept. So negative 3, 0, because it's the x-intercept. The other one is in a coordinate 1, 0, because again, it is the x-intercept. What this chart is doing is telling you the most important coordinates, and we're also going to talk about our domain and range. If we have our coordinates, we can easily graph them so that we can, without our calculator. The next part we're going to look at is this going to be a maximum or a minimum? We really want to know if the graph is going to open up or if it's going to open down. So if we go back to the original equation, the original function, we see that the very beginning, our a value is always in the front, it's our GCF. Our a value is actually a positive 1. We don't see it there, but because there's nothing written there, that's a positive 1 times the factors. So in this case, since it is a positive, we know that a is equal to a positive value. That tells us that our graph is actually going to open up. And if it opens up, we're going to have a minimum. This at least lets us know that when we get our coordinates, if it's not opening up, we know we did something wrong. The next thing we're going to look for is our AOS. Our AOS is called the axis of symmetry. This also helps us with our vertex, because right now we don't have our vertex told to us. We will have to find that. It's going to be the next section. So our AOS is when you actually add the x-intercepts. Then we're going to divide by 2. Now the reason we're actually doing this is because our vertex, the x value of our vertex, is actually directly in the middle of our 2x intercepts. So we're actually going to find the midpoint. So if our 2x intercepts are here, the x value of a vertex will be right in the middle of that. Now it might be below or above, but we can at least find our x value by going to the middle of that. So if we think about, we have a -3 and a 1 are our two values. That's where it's going to cross on the graph. So what value is between -3 and 1? To do that, we use the midpoint, which is x plus x divided by 2. Well, our x's are the m and n, which is, again, what we're using for this video. We're using m plus n because those are our two x value, x intercepts. So what we do is we take x equals, because our axis of symmetry is always an x equals, it's our vertical line. We're going to take our -3 plus our 1 and divide it by 2. We end up with x equals -3 plus 1 is -2 divided by 2. So our axis of symmetry is actually x equals -1. And this is directly in between -3 and a +1 on a number line. The reason we want to find our axis of symmetry first on this part is so that we can find the y value of our vertex. If we have the x value, we can actually substitute it back into the original problem, and all we're left with is the y. So for the vertex, we want to plug in the AOS, the axis of symmetry, for the x value to find the y value. So in this case, we must have x, we have the x, so that we can find the y. We have the x value of our vertex, because that's where the axis of symmetry comes from. And so now we're just looking for the y value of our vertex. What we're going to do is plug it back to the original function. And again, it used to say f of x. I'm just going to use y so that we can see that we have the letter y. So we have y equals parentheses x plus 3, close parentheses, parentheses, x minus 1, close parentheses. This is the original. So what we're going to do is substitute the x value of -1, just like in function notation. We're going to just substitute it everywhere we see an x. We're going to put that -1. So I'm going to have, I don't have a y yet, so I'm going to put y equals parentheses. Now my x is actually -1, so I'm going to plug in -1, and then I see +3. I keep that +3, parentheses, parentheses. Then we see another x. Again, we're going to put that -1, and then we're going to see -1, close parentheses. Now all we do is simplify this. Y equals -1 plus 3 is actually equal to a +2. And then we have -1 minus 1, which is equal to a -2. Now this is actually really important. If you are using your axis of symmetry and you're finding your vertex, then these two values should actually be the same value, just opposites of each other. One positive, one negative. When we multiply these, those will equal to a -4. We have our x value of our vertex, and now we have our y value of our vertex. So I'm going to write this as a coordinate. The x value was that -1, comma. The y value is now this -4. This is now our vertex. So it will be, we have our two x-intercepts. We know we're going to go in between those, and then we're going to go down. So we know that our graph will look something like this. It's going to be an opened up U. And we know that it is supposed to open up. So we are on the right track. The last coordinate we want to find is our y-intercept. And once we have our graph, we can actually do the mirror of the y-intercept, so we can have 5 coordinates total. We want 5. We want the two x-intercepts, we want the vertex, we want the y-intercept, and then the mirror of the y-intercept. Because as long as we have our vertex in the middle, we can actually have everything is going to be symmetrical across from our vertex. So the y-intercept is when you have x equals 0, because the y-intercept is when it crosses the the y-axis, when x is 0. So just like when we did our vertex, we have the x, but we have to find the y. Now in this case, our x is always going to be 0. So we have x, but it always equals to 0 on our y-intercept. Then we just find our y. So we're going to do the exact same thing we did when we did our vertex, the y value of our vertex, but this time we're just going to plug in the x equals 0. So I'm going to write the original problem again. The y equals x plus 3 times x minus 1. And in this case, I'm going to plug in the 0. So y equals, parentheses, everywhere I see an x, I'm going to put a 0. 0 plus 3, parentheses, parentheses, Then again, I see another x. I'm going to put 0 minus 1, close parentheses. Now we're just going to simplify this. This would be y equals, parentheses, 0 plus 3 is 3, and then 0 minus 1 is negative 1. 3 times negative 1 is negative 3. So now our y-intercept, our x value that we plugged in, whatever we substituted for our x is our x value. That's 0, comma. That was our input. Now our output is the negative 3 because that's what we got out from it when we plugged in 0. So our y-intercept is 0, negative 3. Now if we graph this, we can find the mirror of it by going to the other side of our axis of symmetry. This is a quadratic function. That means it is a parabola. Our domain will always be written as open bracket, negative infinity to positive infinity, open bracket. Because this does not have any holes in it. It does not stop. It goes left and right forever. So we have negative infinity to positive infinity. And again, we use open brackets because it never actually touches infinity. So it has to be open. Now our range will always be slightly different, just slightly. Because this will open up, because this is a minimum, you can always see that we're going to have a positive infinity. And positive infinity is always going to be on the right-hand side because it's going to be the largest values. That means that we need to know what our minimum value is because we have a minimum. The minimum value is equal to the y value of our vertex because, again, that's going to be the lowest point. The vertex is always the lowest or highest point. So in this case, whatever the y value is, because the range is y values, it'll be of your vertex. So the minimum value is negative 4. So as long as you can find these pieces of information, you will always be able to answer all of these questions. So our range, I'm going to go ahead and put up my comma there. I have a minimum. And I know since it opens up, that I'm going to have a positive infinity. My positive infinity will always be on the right-hand side. Therefore, I just need to have a number on the left. The minimum should always be on the left. Minimum, maximum. So the minimum will be at negative 4. Now, because it is actually at negative 4, it actually stops there. I'm going to use a closed bracket for that negative 4. But because infinity never touches and we never actually get to infinity, it has to be an open bracket. This is how we figure out all of the pieces of information that we need for our quadratic function. So if we open this up, we're going to do the same thing. And we're also going to graph our functions, but without the use of a calculator. So we're going to find the same information. Now, they might be out of order because these are the pieces that we need, but we have to find them in a specific order. So our x-intercepts are always the first thing that we try and find. Since this is in factored/intercept form, because it is a product of its factors, we can automatically find our x-intercepts. To find our x-intercepts, again, we take the factors, anything that with an x in it. See how the 1/2 does not have an x? Then that is not part of our x-intercept. We want to find our x-intercepts by using our factors. So again, we take the first set of parentheses. What plus 2 gives you 0? We want to find our zeros, or our roots, our x-intercepts, our solutions. This x value, again, we're going to use m and n. M equals n equals. Negative 2 plus 2 gives us 0, so m equals negative 2. This one says what minus 4 gives you 0, and it's 4 minus 4 gives you 0. So our n value is 4. We can write our x-intercepts as negative 2, 0, and 4, 0. We always make sure we try and have 2 x-intercepts. Next up is we want to find our vertex, but in order to do that, we need to find our axis of symmetry so that we can substitute our x value in. So for our axis of symmetry, our AOS is x equals m plus n divided by 2. We want to figure out the value right between the negative 2 and 4. So if you can do that using midpoint or by counting, So we can see our negative 2 and then our positive 4. You can actually find the value in between those two. I'm going to use the formula so that we can get used to it. So we have a negative 2 plus 4, and then we're going to divide by 2. Negative 2 plus 4 is a positive 2, divided by 2 is equal to a positive 1. So our axis of symmetry is always written as an x equals. If you don't have that x equals, it will be incorrect because that tells us it's a vertical line. X equals 1. Now that we have the x value, we can find the rest of our vertex by substituting it back into the function. Now this is h of x. Again, h is a function of x. So that means that this can be replaced as a y equals. So to find the rest of our vertex, we have y equals. Now I'm going to keep everything except when I see the x, I'm going to plug in that positive 1. So I have 1/2 parentheses 1 plus 2 parentheses parentheses. Then it's 1 minus 4. And then we simplify this. This is 1/2 times 3 times negative 3. So again, we have a positive 3 and a negative 3. So that's important to have because we know that our vertex, the y value, should have the same number, but one's positive, one's negative. So that is, we are on the right track. 3 times negative 3 is negative 9, times 1/2 is negative 9 over 2, or really negative 4.5. So when we write our vertex out, we had our x value of 1, that's what we plugged in, that's what we substituted, and we got out the y value of negative 4.5. Now to find the last coordinate we're going to use is to find our y-intercept. Our y-intercept is always going to be plugging in 0, so we can go ahead and actually put 0 comma something. So let's go find that. It's going to be a y equals 1/2 parentheses 0 plus 2, and then 0 minus 4. So we have 1/2 times 2, 0 plus 2 is 2, and 0 minus 4 is negative 4. So 2 times negative 4 is negative 8, times 1/2 is a negative 4. So this is equal to a negative 4. So I'm going to plug that in here, saying y-intercept is at 0, negative 4. These are our coordinates, so now we can just answer the rest of this information. This graph, this function, will open up because a is positive. A is equal to a positive, so then it opens up. Because it opens up, this is going to have a minimum because we have the smaller value. And don't forget, we always want to know what the value is. So value, again, is the y value of our vertex. So what we just found up here is going to be under that value, negative 4.5. Don't forget, we're going to use that when we talk about our range, because that y value is always used for our range, not the y-intercept. Our domain, again, is always written as open bracket, negative infinity to positive infinity, open bracket. Now for our range, we're going to have our comma. Now since it opens up, that tells us it's going to keep going up. We're going to have a positive infinity. Positive infinity is always on the right-hand side. And therefore, I use my negative 4.5 on the left. Close bracket because it stops there. And then open bracket for our infinity. Now to do our graph, we always make sure that we label our x and y axis. Again, the x-axis, we always want to label it on the right-hand side. And then our y-axis, we always want to label it on the top, because these are the positive x's and the positive y's. We do not have to put our count by because our scale is already on here. This is 2. That means that each of them are actually counting by ones, because it goes up to 10. So what I'm going to do is graph our x-intercepts first. It's at negative 2, 0, and at 4, 0. Graphing those in red. I'm going to graph my vertex, which is at positive 1 and negative 4.5. Then I'm going to graph the y-intercept, which is at 0, negative 4, 0, negative 4. Now we also want to have that fifth coordinate, which was that mirror of that y-intercept. So let me draw in our axis of symmetry, which is at x equals negative 1. So that's that dotted vertical line going through the vertex. Now you must label this, and I generally always label it either on the top or bottom, depending on which way it's opening. Since it's opening up, I'm going to label it on the bottom. You have to label it as AOS, axis symmetry, x equals, and then that was equal to 1. So whatever was here is the exact same thing you put here. Now, our y-intercept is one space away from our axis symmetry. So if we go one space away from the axis symmetry continued, then this is going to be the mirror of our y-intercept. We do this so that our graph is as accurate as possible. Now, there are obviously going to be other coordinates that we can find, and you can actually find that by plugging in another x value. So if I wanted to plug in 5 to find the coordinate for the 5, I could plug it in and figure out what that value is. So 5 plus 2 and then 5 minus 4. So 5 plus 2 is 7. 5 minus 4 is 1. So it's 7 times 1 is 7. And then we take half of 7, which is 7. Half of 7 is 3.5. So at 5, it would actually be at 3.5. So I could make sure that my graph goes through that coordinate. And then because, again, axis symmetry, that means that -3 will also be at 3.5. So I'm going to definitely connect these coordinates, but I want to make sure it extends. So I like to try and start with my vertex to make it try and go as cleanly as possible. I will continue it up and make sure I have an arrow on the end of that. Then I'm going to do the other half of my graph and try and do the same thing. I know it keeps going up, and I do make sure it tries to keep going to the left and to the right. And this is our graph for this problem. And we can graph this in our calculator. You can always graph this back in your calculator to make sure it does work. So if I go into my calculator, I'm going to go to my y equals. I'm going to type my original function in, which is 1/2. Now, my calculator, I want to make sure my fractions are always in parentheses, just because I want to make sure it stays as a fraction. Parentheses, x plus 2, parentheses, x minus 4. Now I want to press graph. I can see that my graph does look similar. I can see that it's slightly off of the y-axis like it is here. I can also go to my coordinates, my tables. So second graph, and I can find these coordinates. So -2 is at 0. +4 is at 0. My 1 is at -4.5. And my 0 is at -4. So I was correct on all of these coordinates. And then I can make sure that they are graphed correctly. On this last one, I'm going to do the same thing. I'm going to go a little bit quicker on this. So the first thing is our m and n. Again, what minus 3 gives you 0? So m is +3. What plus 1 gives you 0? So n is equal to a -1. So our x-intercepts are at 3, 0, and -1, 0. Next up, I'm going to find the axis of symmetry so that I can actually find my vertex. So AOS, x equals, it's 3 plus -1 divided by 2, which again, 3 plus -1 is 3 minus 1, so that's 2 divided by 2, which is equal to 1. So our axis of symmetry is x equals to 1 again. It won't always equal to 1, that was just a coincidence. So now that I have my axis of symmetry, I'm going to find the rest of my vertex. So for the vertex, it's going to be y equals, because f of x really means y, -2 parentheses. I'm plugging in my 1 for my x, so it's 1 minus 3, parentheses, 1 plus 1, parentheses. So we have -2 times 1 minus 3 is -2. 1 plus 1 is 2. -2 times -2 is +4, times 2 is +8. So our vertex is at the the axis symmetry is at 1, comma, then the y value from that was 8. So the last coordinate we're going to actually have to solve for is our y-intercept. Again, the x value is equal to 0, so I can go ahead and put 0, comma. So we have y equals -2 times 0 minus 3, and then 0 plus 1. So we have -2 times -3 times a +1. -2 times -3 is +6, times 1 is +6. So our y-intercept is at 0, 6. Now looking at the a value at the very beginning, that -2, since a is equal to a negative, that means it's actually opening down. And because it's opening down, we're going to have the highest point, which is a maximum. We always want to make sure we know what that maximum value is. That value comes from the y value of our vertex, that 8. Because our minimum or maximum, the vertex is called your minimum and maximum. Your domain is still open bracket, negative infinity, comma, positive infinity, open bracket, because it keeps going to the left and to the right. Our range, I'm going to go ahead and put that comma. Since it's opening down, we're going to have a negative infinity. And following the domain, negative infinity is always on the left-hand side. And then I'm going to have a number on the right-hand side, which came from the value right above it. So we have 8. The negative infinity has an open bracket. 8 has a closed bracket. I'm going to use these coordinates, these 4 coordinates, and then we're going to do the mirror of the y-intercept to graph. First stop is putting the x on the right-hand side and the y up on the top. Again, we don't have to put our count by because the scale is already on there. X-intercepts are at +3, 0, and -1, 0. Our vertex is at 1, 8, +8. And you can see that the 1 is actually 2 spaces away from the 3 and 2 spaces away from the -1. So our axis symmetry, that's again why we have the axis of symmetry going through the middle. It is specifically right in the middle. So this is AOS x equals 1. I labeled it up the top because I know that my graph will open down. Now I'm going to do my y-intercept, which is at 0, 6. And I want that 5th coordinate, which is the mirror of the y-intercept. So I go to get to my axis of symmetry, I go to the right one, I go right one more. And then I put that coordinate. Now that I have my 5 points, we can graph this as much as we can. So when I graph this, I'm going to make sure that I have I start from my vertex, and then I connect my points. And I know that it's going to keep going. And then I do my other side. It's going to keep going, and I have my arrows at the end. And again, we can go back to our calculator and check it. So I go to my y equals, I type this in, -2 parentheses x minus 3 parentheses parentheses x plus 1 parentheses. Press graph. And that is what our graph looks like. I can go back to my table, my coordinates, to see if my coordinates are in fact correct. So second graph. One of my coordinates is 3, 0. I was correct on that one. And then -1, 0 was also correct. 1, 8 was correct. And then 0, 6 was correct. Now I can also see other coordinates here. And do you notice that these values are the same as you get closer and closer to that 8? It's because this is symmetrical. That 1, 8 is your vertex, and you can see that by the 6 and 6 and the 0, 0, -10, -10. So my -2 value should have actually crossed at -10, and then my 4 value should have crossed at -10, which I got pretty close to it. This is how you actually graph and do the charts, the important information when you're in factored or intercept 4.